Okay, today's lesson we are going to go over parallel and perpendicular slopes. So we have two objectives today. The first one is on just identifying parallel and perpendicular slopes, and the second one is going to be making the equations using parallel and perpendicular slopes. So there'll be times where we'll pause and you can go to the learning log and try if you want, or you can just power through. So the first objective is determining parallel and perpendicular. So I have on this first slide here are the two different parallel versus perpendicular definitions. So feel free to either copy this down or you can screenshot it. Some of this stuff you're not going to know, but you're not going to need to know, but I just wanted to go through the important characteristics. So the first one is parallel, and right down here is the picture of parallel lines. And so parallel lines, if you remember, they do not intersect, they run in the same direction. So that's like the geometry part of it. But the algebra part of it is that the slopes are equal. That is the important part right here, and that's what we are going to really focus on today. The algebra part is that the slopes are equal. So if you look down here, you can see that the slope of the red line is -5/3, and so is the slope of the blue line. So that's the important thing to learn about parallel slopes today, is that they are equal. They never intersect each other because they are exactly the same. They're always going to run in the same direction, same slope. The second one is perpendicular. And so perpendicular lines, which is this picture right here, are lines that are completely opposites. And if you remember back in geometry, which you probably had like last year, is that they also form 90-degree angles. So they're 90-degree angles, perfect right angles all throughout here. So that's how you know that they're perpendicular geometrically. But algebraically, this is the important thing, is that the slopes are opposite and they're reciprocal. So in case you forgot what that means, opposite means that it is the opposite sign. So for example, if one of them is positive, the other one has to be negative. And so you can see here in their slopes, you have a positive 3/4 and a negative 4/3. So in order for them to be perpendicular, they have to be opposite of each other, meaning the sign has to be one positive and one negative. And then the second thing is that it has to be reciprocal or flipped. So you'll notice in the fraction here that the first one is 3/4, but then the other one is 4/3. So not only did the signs change, but they also flipped their positions, numerator and denominator. So those two things have to happen in order for them to be perpendicular. Okay, so let's keep that in mind, and we're going to practice that on the next slide. Okay, moving on to the next slide. So the first thing that I'm going to ask you to do is just kind of look at an equation and just tell me, looking at this, what would be a parallel and a perpendicular slope. So let's start with A. So we first want to look at what is the actual slope. And so the slope here is, okay, so the slope here is 2/3. And so if I were to ask you, I'm going to draw that this is just the sign for parallel instead of writing out the whole word parallel. So a parallel slope would be exactly the same as the slope. So a parallel slope to this line would still be 2/3. I know it seems kind of silly, but just want you to understand and recognize that parallel means that they are the same. Now perpendicular would be this sign. That's the symbol geometrically for perpendicular. Perpendicular, we would want to flip it. So we would want to reverse the fraction into 3/2. And then because it was positive, we want to make it negative. So that would be the perpendicular slope for 2/3. So that's all I'm asking you, and that's all I'm looking for right here. Then the second one, okay, this time we have a slope of -5. Come on, get my cursor here. There we go. So a slope of -5. So a parallel slope to -5 would just be -5, exactly the same. But now a perpendicular slope, okay, we have to flip this. So how do I flip a whole number? Remember that a whole number is always over 1, even though it's not written. We can write it as a fraction as -5/1. So to flip that, we would want to put the 5 at the bottom. So a perpendicular slope would be 1/5. And then it's going to stay positive now because it was negative, and now it has to change to a positive 1/5. So that would be the perpendicular slope. Okay, the next thing then that I might ask, or you might see, and some questions is determining just comparing now. So here's an example of how you might have to compare. So this time I'm giving you two different equations and I'm asking you to determine, to compare the two of them. Are they parallel? Are they perpendicular? Or they are not related at all? So in this case, the first one, which we always want to make sure, notice how this is in y equals form, perfect, that's what we want. But the second one is not in y equals form. Want to make sure that that's in y equals form. We cannot analyze unless it is in y equals mx plus b form. So I'm going to move that 4x over to the other side. And my equation now is y equals negative 4x plus 2. Now I can analyze. So these are the two that I want to look at and analyze. And remember, I'm just looking at their slopes. I don't care about the b. This 2 and the 3 isn't going to tell me anything about the direction that they run. These are the important numbers right here. So the 1/4 and the negative 4. So we know right away these are not parallel because they're not the same. So the next question is, are they perpendicular? They are opposites. One's positive, one's negative, check. And they are reciprocals because the opposite of 1/4 or the reciprocal of 1/4 would be 4/1. So these two lines are perpendicular. Okay, if they don't follow any of those rules, then you would just put neither. All right, so that is the first objective. If you would like to pause and take a moment to process and go to your daily learning log, you can try the first objective questions just to practice, or else you can keep going and I will keep going with the second objective. All right, second objective is, now I'm going to take this and we're going to put everything together. So everything that we worked on Friday, and we're going to tie together parallel versus perpendicular today. So I put some steps up here. Again, you can screenshot it or feel free to take down notes, whatever's easiest for you, but just some things to remember as you're doing this, or you can just write down the example, whatever is easiest for you. So the first step is to make sure that your y is isolated. So in our first example, we are very fortunate. Y is isolated, so I'm going to move on to the next step. Step number 2 is identify the slope that we need to use. So in the problem, they mentioned that I need a parallel equation. I'm making a new equation that is parallel. So since they want parallel, I want to make a parallel slope. That's why we practiced that earlier. So a parallel slope to this line, our slope is 3, a parallel slope would just be 3. So that's the one that I'm going to use when I say identify the slope. That's what I want to use is 3. And now I'll keep going. So remember that your slope is the same as your m. And so now if you'll notice, this is looking really familiar to what we did on Friday. So I have my m, and they also gave me these points of -1 and 4, which are my x and y. So now what you're going to do is you're going to find a brand new equation. So a brand new equation different than the one they gave you. It is going to use this slope, and it has to run through the point that they gave you. So we're going to take, this is step number 3 now, we're going to plug into y equals mx plus b, the numbers that I have, just like we practiced on Monday. So everything that we're doing right now is, you got this down. So my y is 4, so it'll be 4 equals m, which is 3, times my x, which is -1, plus b. Okay, 3 times -1 is going to give me -3. And then I have to add the 3 over to the other side. Come on. Great. Sorry about that. Little slip. Okay. So I'm going to add the 3 over here, and I should have b is 7. So then just be careful not to finish the problem, because what they wanted was they wanted the equation. So they didn't want you just to find the b, they want you to find what is your new equation that is parallel. So go back, step number 4 is write the final equation in y equals mx plus b form. So y equals my slope of 3, x, and my new b of 7. So the most common mistake I see is that students try to use this 1 that's in the given equation, the b. That 1 is not important. You're not going to use that 1 at all. You're finding a new b, so we found 7, and now if you look here, these equations are parallel to each other. That's our goal. So just be careful, don't use that b, And then don't forget to do step number 4 and write your final equation. All right, let's try an example of a perpendicular, just to show you what it might look like. Okay, perpendicular. So first step is to make sure that y is by itself. And as we can see, y is not by itself. So I'm gonna go ahead and solve for y. So I'm gonna add the 3x to the other side. So I'll have 2y equals, ooh, the equal sign was rough, equals 3x plus 8. Okay, then I'm gonna divide everything by 2. And you wanna keep your slope in a fraction. We don't wanna change that to a decimal. Remember, if we are graphing this, we wanna leave it as rise over run. So we're gonna leave that as 3 over 2x and then plus 4. And that's okay, leave it as a fraction. I tried to make it easy so it's gonna cancel out for you. Okay, so that was step 1, solve for y. Step 2, identify the slope that you need to use. And so in this case, we want a perpendicular slope to the one that is given. So we don't want the parallel slope this time, we want the perpendicular slope. The perpendicular slope would be a negative 2 over 3. We have to change it to a negative and flip it. And remember, that's your m. So now that we have our slope that we want to use and we have our x and our y, we're going to plug it into y equals mx plus b, which is step 3, and find our new b. Okay, remember when we're plugging these in, we are not using this b over here. Ignore this b, it's not important. We're only going to use the m, x, and y in our equation. So y is negative 6, so negative 6 equals negative 2/3 times 3 plus b. Now, if you do this in your calculator, don't be scared of this fraction, because what happens is the 3's are actually going to cancel out. Negative 2/3 times 3 is going to give you just a negative 2, because those end up canceling top and bottom. And then we're just going to add the 2 on both sides. Add the 2 on both sides, and so you'll have b is negative 4. So my final answer then is, remember you got to write the final equation, y equals my new m, the perpendicular m of negative 2/3 x minus 4. That's my new b. So that is the perpendicular equation to that guy right there that we started with. And that's it. All right, then you can try those on also the daily learning log. There's one of each of those on the learning log for you to try.